A dewatering system is used in pipe laying to remove water from the trench where the pipe is being installed. This is typically done using pumps or other equipment to draw the water out of the trench and into a collection area or drainage system. By removing the water, workers can more easily access the trench and install the pipe, while also reducing the risk of damage to the pipeline caused by water pressure or erosion. Dewatering systems can vary in design depending on the specific needs of the project and the types of soil and groundwater conditions present in the work area. Types of dewatering systems. 1. Well point system. This involves installing shallow wells around the work area and pumping water out of these wells using vacuum pumps. 2. Deep well system. This involves drilling a deep well and installing a submersible pump to draw water out of the ground. 3. Eductor system. This involves using a high-velocity jet of water to create a vacuum that draws water out of the ground and into a collection system. 4. Horizontal well system. This involves drilling a horizontal well and installing a slotted pipe to allow water to flow into the well, where it can be pumped out. 5. Open sump pumping system. This involves excavating an open sump and pumping water out of the trench into the sump, where it can be collected and removed. In Rathmalana Marachua wastewater disposal project, we use well point dewatering system to lower the groundwater level. In these areas, normally groundwater table is about 1.5 meters to 2 meters. Therefore, in the design it has decided to use well points for every 1 meter intervals. Apparatus of well point system. Procedure of well point system. First, we need to prepare the pipes to be used in dewatering wells. For this, we use diameter of 1-inch PVC pipes. A net should be wrapped around the edge of the pipe. It acts as a filtering media and reduces the blocks that may occur in vacuum pipe network. Then, we dig holes initially using a crowbar in 1-meter intervals. These gaps may vary due to the ground conditions present in the area. When digging these holes, make sure to avoid damages that may cause to any utility pipe underground. Next step is to prepare the water pressure pump, which is used to drill the initial hole we dug earlier. After necessary arrangements, we can start drilling holes using water pressure pump. After detaching the water connection, install the PVC pipe into the hole that we drilled. Then, these pipes will be connected to main dewatering network using hoses. This method of releasing collected water from the top of the barrel allows to sediment silts and other particles. Collected water should be released to the drain properly and desired groundwater level of the working area can be maintained. Pumped out groundwater should be discharged further away from the working area. After successfully dewatering, we can change the behavior of groundwater table as follows. In Rathmalana, Marachua area, the groundwater level is around 1 to 2 meters. In Rathmalana Marachua Wastewater Disposal Project, we have achieved perfectly dry conditions in the trench bed by following the swell points method. Problems that may occur in dewatering. 1. Clogging. The well points can become clogged with soil or other debris, reducing their effectiveness. Therefore, the well points should be checked and cleaned regularly to prevent clogging. 2. Pump failure. The pump can fail, leading to a loss of vacuum pressure and reduced water removal. Backup pumps can be installed to ensure continued water removal in case of pump failure. 3. Uneven dewatering. The system may not remove water evenly from all areas, leading to uneven ground settling or other issues. To minimize this, the system should be designed and installed properly to ensure even water removal and prevent settling or other issues. One potential problem with a well point dewatering system is that nearby wells and ponds may dry up due to the removal of water from the ground. This can have negative impacts on the local ecosystem and community. To address this problem, potential solutions include assessing impacts before installation, monitoring water levels continuously, supplementing nearby water sources, or using alternative dewatering systems with less impact on nearby water sources.